All right, we're recording. All right, so the next section next week is 7741, and we're going over configuring DNS servers. So like I said on all the other stuff, if you have any questions, stop me. So we're going to cruise through this one tonight. All right, so we've already gone over DNS stuff a little bit, so some of this is going to be a little repetitive, but stick with me. Domain name system, or DNS, is a distributed hierarchical database composed mainly of computer name and IP address pairs. Distributed means no single database contains all the data. Hierarchical means there's no structure to how information is stored and accessed in the database. In order to resolve a name to an address, a DNS lookup will often require multiple queries to a hierarchy of DNS servers. DNS can be described as an inverted tree structure. Ow, that's my leg. Sorry. Name structure is called the fully qualified domain name, or FQDN. The entire DNS tree is called the DNS namespace. Each domain has one or more servers that are authoritative for the domain. Apparently, Grumpy Cat is just going to come randomly run across our space, so I apologize. Root servers keep a database of addresses of other DNS servers, managing top-level domain names called top-level domain, or TLD, servers. And you can see they have a nice little graphic there where it starts at root and goes all the way down. So you have your top level, second level, and then your subdomains that are listed. A zone is a grouping of DNS information that represents one or more domains and possibly subdomains. Zones contain a variety of record types called resource records, which contain information about network resources. DNS resource records are identified by letter codes. I have learned a valuable lesson, and that is if the cat finds a catnip toy right before class, hide it, because I think I've got a couple of really high kitties running around right now. Two types of DNS lookup can be performed. Iterative query. A DNS server will respond with the best information it has to satisfy the query, or it may give a referral response. And then there's a recursive query. A DNS server processes the query until it responds with an address that satisfies the query, or with an I don't know message. A typical DNS lookup made by a DNS client can involve both recursive and iterative queries. DNS clients maintain a text file that can contain static DNS entries, and the file is stored, you can see there, at system root, whatever the system root is, and then system32 drivers, etc. And here is your example of what the steps are for this. So step one, you have your recursive query for this, they're using Microsoft.com. Iterative query to root server, step 2. 3, try one of the TLD servers. Then 4, iterative query to COM TLD server. 5, referral, try one of the Microsoft.com DNS servers. Then you see it over here on 6, iterative query to Microsoft.com DNS server. And then, there's the address. And then up there it goes, here's the address, and gives it back. So you have this nice little bing, bing, bing around, and it shows where that goes. DNS server roles. DNS servers can perform one or more of the following roles for a zone. Authoritative server holds a complete copy of a zone's resource records. Forwarder, a DNS server to which other DNS servers send requests they can't resolve themselves. Conditional forwarder, a DNS server to which other DNS servers send requests targeted for a specific domain. Caching only server, does not have zones, and its job is to field DNS queries, do recursive lookups to root servers, or send requests to forwarders, and then it just caches the results. Okay, before I hit on installing DNS, so far, does that make sense for everybody? Crickets, yep, okay. So installing DNS, correctly configured and efficiently functioning DNS service is essential for well-functioning networks. You can tell really quickly if there's something wrong with your DNS service. When domain controllers replicate with one another and when trusts are created between domains in different forests, DNS is required to resolve names and services to IP addresses. With Active Directory installing DNS, during Active Directory installation, Windows attempts to find a DNS server. If it's unsuccessful, it asks whether you want to install DNS. That's actually a good point. If you open up Google and you get the little dinosaur that comes across that says, I don't know what's going on. Yeah, that means there's something wrong with your DNS. Usually there are, sometimes there can be other things, but usually that's what's going on. When a new forest is created, it is best to have Windows install DNS during Active Directory installation. If the DNS server is intended to manage domain name services for Active Directory, DNS server role should be installed on a domain controller. Windows automatically detects whether or not the server is configured as a domain controller, then integrates DNS zones with Active Directory. Installing DNS on a nano server. Deploying DNS on a nano server is ideal for small footprint and can be managed remotely. DNS on nano server doesn't support Active Directory integrated zones, so keep that in mind. Installing DNS on a nano server. So you create a nano server virtual disk image with the DNS server package by using the packages Microsoft Server DNS package option. Once the nano server image is created, start nano server, and from remote PowerShell prompt, use the enable Windows optional feature, online, feature name, DNS server full role, commandlet to extract the DNS server role and the associated PowerShell commandlets. And you'll just see it if you've ever done anything like this, you'll just see it start running a bunch of things in there. Import the DNS server module using the import module DNS server commandlet. Make the DNS management commandlets operational using the get command, module DNS server commandlet. Configuring DNS. 3 aspects of DNS configuration. So you have the DNS zones, DNS resource records, and DNS server settings. You may need to create a zone manually in DNS Manager if you don't install DNS at the time you install Active Directory. Install DNS on a server that is not a domain controller. Create a stub zone. Create a secondary zone for a primary zone. Create a primary or secondary zone for an internet domain. Forward and reverse lookup zones. 2 DNS zone categories that define what kind of information is stored in a zone. You have an FLZ, forward lookup zone, which contains records that translate names to IP addresses such as AAAA, and MX records. Then you have the RLZ, or reverse lookup zone. This contains PTR records that map IP addresses to names and is named after the IP network address, IPv4 or IPv6, of the computers whose records it contains. There are 3 different types of zones. You have your primary, secondary, and stub zone. Primary zone contains a read-write master copy of all resource records for the zone, and it is considered authoritative for that particular zone. Secondary zone contains a read-only copy of all resource records for the zone and is considered authoritative for that zone. Then there's stub zone, which contains a read-only copy of only the SOA and NS records for a zone and the necessary A records to resolve the NS records. And a stub zone is not authoritative. Zone name. The next step is to give the zone a name. For an FLZ, it is the FQDN. For an RLZ, specify whether it is an IPv4 or IPv6 zone. Then enter the network ID portion of the zone. The zone name is created automatically by using the network ID's octets in reverse order and appending the IN, ADR, ARPA to the name. Zone file. If creating a standard zone, you specify the file name in which to store zone data. Default name is zonename.dns, where zone name is usually the FQDN. So you see your example down there on your wizard. This one's csmtech.local.dns. And you can change that to whatever it is you need for that. Dynamic updates. Final step allows you to choose whether and how to use dynamic updates, which can be configured in one of three ways. Allow only secure dynamic updates, allow both non-secure and secure dynamic updates, do not allow dynamic updates. Dynamic updates enable DNS clients, computers to register and dynamically update their resource records with a DNS server whenever a change occurs. And here's your example of what that screen looks like. And you can see allow only secure, both non-secure and secure, and then do not allow. Is this making sense so far? So far-ish. Yeah. Yeah, I'm going to say yes and then just cry later. Fair. That's fair. Okay. Configuring DNS with PowerShell. The following commandlets cover installing DNS and creating a new zone. So there's the install Windows feature, DNS, include management tools. This installs DNS and DNS management tools. Thankfully, most of the PowerShell stuff will say pretty much exactly what it does in the commandlet. Add DNS server primary zone, CSM tech local zone file, creates a, and then, that thing there, creates a standard FLZ named that and stores it in a zone file named that local.dns. Add DNS server primary zone, network ID, and then you have your network ID, and then zone file, and then you have your zone file. That creates a standard RLZ for your network ID and stores it to a zone file named. So that's just giving you examples there. Creating DNS resource records. Resource records can be created dynamically or as static records. Dynamic records are created by the resource or with a DHCP server. Static records are created manually by an administrator or automatically by Windows. Here's your host A and AAAA records. Host record consists of a host name and an IP address. The most abundant type of record is a typical DNS primary or secondary zone. Can be referred to as an A record when it's the IPv4. So if you don't know what they're talking about there, A record is your IPv4, and then the quadruple A is when they're talking about the IPv6. Canonical name or CNAME records. And I can guarantee not very many network admins will say canonical name. They just say CNAME records. CNAME record is an alias for another domain name record in the DNS database, used when multiple services are running on the same server and you want users to be able to refer to each service with different names. Can also create CNAME records that point to records in other domains. So you can see down here, you have your record name, the types of record names. So you have your CNAMEs, www.csmtech.local, and then it says that server one, csmtech.local. And then there's another CNAME for FTP, csmtech.local, and that one's also on server one, csmtech.local. And then the A name points that server one over to the IP address. Does that make sense on those C names and A names?
It makes sense, but can you give an example of the difference between the www and the FTP one? Like FTP would just be the simple like downloading a file versus www being their
Exactly.
homepage for a website.
So an HTTP would just be your regular unsecured, website, not an HTTPS site. It's just an HTTP site. You actually have a different one, a different C name for HTTPS. So the FTP for that one is just your file transfer protocol. And then your A name is just pointing out your IPv4 version of that IP address that points to that particular server.
Cool. Thank you.
Does that make sense? Okay. Good.
Yeah.
PTR records, pointer records, are used to resolve a known IP address to a host name. These are useful for certain applications when only the IP address is known and you want to find the host name. PTR records are found only in RLZs. They have much of the same information as a host record. When you create a host record, you have the option to create the related PTR record for the host automatically. So whenever you see MX, they're talking about mail exchanger records. MX records are used by mail services to find the mail server for a domain. When an outgoing mail server needs to deliver an email message, it performs a DNS lookup for your MX record for the domain name contained in the email address. To create an MX record, right-click on the zone where you want to create the record and click New Mail Exchange or MX record. If you're doing anything with servers or if you're doing a lot of web server stuff, you may have some experience with this. That's where a lot of mine comes from, my experience. I did a ton of web app and web server development, and that's where I learned all of this stuff. So this is what your new resource mail exchange record looks like. You type in your host or child domain, and then you have your fully FQDN, your fully qualified domain name. And then if you look down, you have your server priority and you have all the other stuff you can add in there. SRV or service location records. An SRV record specifies a host name and port number for servers that supply specific services. SRV records are critical to the operation of an Active Directory domain. Without them, client computers couldn't find domain controllers or global catalog server to log on or join a domain. SRV records for Active Directory are usually created automatically when Active Directory is installed. Pretty much all of the ones I've dealt with have been automatically done unless there has been something very, very wrong that's happened and you have to go in and manually do it. Okay, so this is an example of what this looks like for the DNS manager. And this is your LDAP properties, just so you can see what that looks like. As you can see, you have your domain on the top and then your port number that they're talking about right there. Questions before I go on? I know this is a lot of dense numbers and things like that. Okay. Creating dynamic DNS records. Dynamic DNS records are created and updated by the resource or by the DHCP server when an IP address is leased or renewed. Each time a dynamic record is created or updated, a time to live or TTL value is timestamp are added to the record. The TTL specifies how long the record should remain in the DNS database. If the record expires, it's deleted from the database. So do any of you know what happens when that record hits the end of its TTL? With a dynamic DNS? Yes, no, we don't know. Brain hurts. It gets another life. It's respawned at its respawn point. Kind of. What it basically does is it just automatically, if it's still out there and it's still trying to use that service, it will reach out and try to get another dynamic. It will reach out and get another record dynamically assigned to it. Just kind of like when you do dynamic IP addresses, when you're doing just regular IP addresses with computers. When you do static, you manually put those in, but you can do a TTL on those when it comes to dynamic IP addressing and force them to periodically check in and say, yes, this computer is still alive. And if they drop off and it doesn't hear from it for a while, it's forced to go back and request a new address. It's kind of the same thing here. Exactly. Yeah, exactly it. Okay, creating static DNS records. Static DNS records do not expire and are created manually by an administrator. To create a static record in the DNS manager, right-click the zone and select record type. In FLZ, the most common type of record is a new host record. Enter a name to create the FQDN automatically. If you select the Create Associated Pointer PTR record checkbox, a PTR record is created if a suitable RLZ exists for the IP address entered. So this is what it looks like. So you do the name, and it uses, if it's left blank, it just uses your parent domain. And then it's got your whatever FQDN is there, and then your IP address, and then you just check that box, hit add host. Okay. Now on to a whole bunch of PowerShells. So get ready for your brain to hurt more. That's a lot of scary. I know. This is why I highly suggest, and it's why I also put out all of these PowerPoints. Sorry, I keep saying power, and I'm like PowerShell. Why all the PowerPoints are out there, so you can go out and just look at them and copy all this information. Because I can read these at you all you want, but having them actually there so you can work with them is a lot easier when it comes to these. So PowerShell commandlets used to create DNS resource records. There's the add DNS server resource record. So this one's for an A, and then zone name, and then you have your zone name, name, host one, and then your IPv, and you can see how it says this is an IPv4 address, and then it gives your IPv4 IP address. This adds an A record named host one to the CSM Tech local zone. Now the second one is adding a quadruple A record for an IPv6 to so it adds your quad A record to named host one to that same CSM Tech local, and it's an IPv6 record. So the next one is to add a CNAME alias record, and that one is named H1 with the target host one CSM Tech local. And the one on the next one, that's your PTR or your pointer record for the named host one, the one above it, with the IP address there, and then there's the pointer underneath it. I fully expect, like when I taught martial arts, if you retain 25% of this directly after the lecture, great. But don't expect to ever retain 100% of something that is this information dense. That's why I have the recordings, and that's why I always have all of those out there for you guys to look at. So don't be surprised that your brain hurts. And my other favorite thing is Google cheat sheets. I cannot stress that enough. Google cheat sheets. They are your friend, especially with PowerShell commandlets. And there are so many, so many of them out there. If you guys find some really cool ones, post them, share them with everybody. We can all use them. I still find new ones out there that I can use. All right, configuring DNS zones. Zones can be viewed and changed in your DNS manager. DNS Manager provides the following options. You can do status, type, replication, dynamic updates, and aging. And you can see here your status. You can see your aging down there. So you can see all of that right here on this screen. I will say that PowerShell is very, very strong, but starting out with the GUI is much easier. Get your feet wet, start out with that, and then go into the PowerShell. That is how I did it, and it just kind of gives you like baby steps into the dark waters of the networking stuff. And like I tell everybody, I don't expect you to remember everything, but I do expect you to know where to look for it. So Google is your friend. Start of authority records. Okay, an SOA record or SRA records are found in every zone and contain information that identifies the server primarily responsible for the zones, as well as some operation properties for the zone. The SOA record contains the following information: serial number, primary server, responsible person, and minimum default TTL. And then later, we discuss the other fields, which are refresh interval, retry interval, and expires after. And here is your example. And you can see here, you have your serial number, server, responsible person, refresh interval, retry, expires after, minimum, default, TTL, and then there are other tabs up there, but that's just the one that they're talking about right here. Name server records. NS records specify FQDNs and IP addresses of authoritative servers for a zone. NS records are also used to refer to DNS queries to a name server that has been delegated authority. You guys can't hear that really awful leaf blower in the background, can you? Oh, good. It's just really annoying, and I was hoping that you guys could hear me over it. My neighbors apparently decided that right now is when they have to do some lawn work. Soul crushing anxiety, yes. Deep breaths. And remember, you can go back and look at the recording. NS records are also used to refer to DNS queries to a name server that has been delegated authority for a subdomain. Glue A records are A records containing a name server's IP address and are used to resolve NS records information. So NS records are like NS lookup. If you've heard of that, that's what they're talking about. On Windows DNS servers, glue records are created automatically by a DNS lookup on the NS records FQDN. So here is an example of what that looks like. So the first part is the FQDN that they're talking about. Creating secondary zones and configuring zone transfers. When a secondary zone is created, it must have the same name of an existing primary zone. The zone transfers must be configured to load data from the primary zone to the secondary zone. Secondary zones are read-only. All changes to the zone data occur at the server hosting the primary zone, are subsequently transferred to all secondary zone servers. Only one server can host a primary zone. Multiple servers can host secondary zones, hence why it's called primary and secondary. Zone transfer settings. A zone transfer copies all or part of a zone from one DNS server to another and occurs as a result of a second server requesting the transfer from another server. Zone transfers can be initiated in two ways: a refresh interval or DNS notify. Zone transfers are configured in the Zone Transfers tab of a zone's properties dialog box, which has the following option. Allow zone transfers to any server, only to servers listed on the Name Servers tab, only to the following servers. Notify. So here is your example of this test DOM1 local properties, allow zone transfers, and they've chosen only to servers listed in the Name Servers tab on this one. Configure timing intervals of zone transfers in the Start of Authority tab. Refresh interval specifies how often a secondary DNS server attempts to renew its zone information. Retry interval as the amount of time a secondary server waits before retrying a zone transfer that has failed. Expires after is the amount of time before a secondary server considers its zone data obsolete if it can't contact the primary DNS server. So they go in steps, refresh, retry, expire. Does that make sense? Full versus incremental zone transfers. And I saw a question about something with UPS. What do you mean about the fake website? Usually what they do is you see what looks like the UPS link, but you hover over it and it's actually a different link. Yeah, it's so it's not unless it's actually been DNS poisoning, it's not actually changing anything with the link or the records. Most of the time they try for the low-hanging fruit and they just go, hey, this is what it actually says. And most people don't actually check the text. Oh, my bad. They just click on the link because they're like, oh, link, yeah, link. And I don't know how many times I have to tell people, you can hover over it to verify what it is, but that is one of the most difficult things I have ever taught people. I don't know why, but it's like, it takes 2 seconds, but it's too hard. I don't know. Okay, 2 types of zone transfer: full zone transfers and incremental zone transfer. During the initiation of an incremental zone transfer, the serial number decides whether the slave or the master determines the differences between its current zone data and the zone data on the other server. If the slave zone is lower than the master determines the difference between its current zone data and the slave zone data. Using WINS with DNS. WINS is Windows Internet Name Service. It's a legacy name service used to resolve NetBIOS names, sometimes referred to as single label names. Similar to DDNS in that it keeps a database of name to address mappings, generally used in environments that require NetBIOS resolution or where applications depend on it. The WINS tab has the following options: use WINS forward lookup, do not replicate this record, IP address, and TTL. Using the global name zone, or the GNZ, allows administrators to add single label names to DNS, giving client computers the ability to resolve these names without including a DNS suffix in the query. Entries must be made manually, can assist mobile users by dropping the need for remembering the resources FQDN. Use the following PowerShell commandlet to enable GNZ. So set DNS server global name zone -enable and then true. Configuring DNS server settings. DNS server settings to configure an optimal DNS environment and solve DNS problems when they occur. Forwarders, route hints, round robin, recursion, debug logging. DNS forwarders. Referring a DNS query to a forwarder can be more efficient under some situations. When the DNS server address for the target domain is known, when only one DNS server in a network should make external queries, when a forest trust is created, When the target domain is external to the network and the external DNS server's address is known, conditional forwarding allows queries for particular domains to particular name servers and all other unresolved queries to a different server. Configuring traditional forwarders. To configure a traditional forwarder, right-click the server node in the DNS manager. Pretty much everything you right-click and go to properties if you need to change it. Click the forwarders tab. If more than one server is specified, they are queried in order in which they are listed. Additional servers are only queried if the first server provides no response. No response from any forwarders triggers a normal recursive lookup process, and it starts with a root server. So conditional forwarders are configured in the conditional forwarder node in the DNS manager. With forwarders and or conditional forwarders configured, the DNS server attempts to resolve DNS queries in this order. It's kind of like when you're thinking about firewall rules, how you start from the top down. So from locally stored zone resource records, then from DNS cache, then from conditional forwarders, then from traditional forwarders, then recursively by using root hints. Root hints consist of a list of name servers pre-configured on Windows DNS servers that point to internet root servers. These servers contain lists of name servers that are responsible for top-level domains. Remember that graphic in the front where we had root and then top level? That's what they're talking about. Root hints data comes from the cache DNS file located in system root system32 DNS folder. Internal DNS servers can be configured as root servers if the network is isolated from the public internet. Round robin. Load sharing can be configured among servers running mirrored services, accomplished by creating multiple A records with the server's name in the records, but with each entry configured with different IP address. DNS will then respond to queries by sending all addresses associated with the server's name, but will also vary their order. This process is called round robin because each IP address is placed first in the list an equal number of times. I believe so. I'm going to have to look that up, but I believe that would be technically a root DNS because that's the one that that's Google's. If it's not root, then it's top level. Recursive queries. Recursion is enabled on Windows DNS servers by default, but there are two ways to change this setting. First involves configuring forwarders. Second is the disable recursion, also disables forwarders option in the advanced tab of the DNS server's properties dialog box. You might want to disable recursion when you have a public DNS server containing resource records for your publicly available servers. Event and debug logging. When DNS is installed, a new event log is created to record informational error and warning events generated by the DNS server. Common events include zone serial number changes, zone transfer requests, and DNS server startup and shutdown events. DNS audit events and analytical events are DNS audit events track changes to a DNS server, such as when a zone or resource changes are made, and DNS analytic events are created every time DNS sends and receives information. Analytic events are disabled by default. So here's your example of that property for event logging. And on this one, they have all events listed. And this is your debug logging screen, and these guys have like everything selected. You can enable in the server's property dialog box record selected packets coming from and going to the DNS server in a text file. That way you can go and look things up if you ever have anything you need to check on. I am not going to read all these for you because that's one of those you'd probably start bleeding out of your ears and eyes things. But this is a nice little table that you might want to screenshot or copy for yourself. It's a nice list of your PowerShell commandlets, descriptions and example of how they will be run. Monitoring and troubleshooting DNS. Stop being a jerk, Kat. To troubleshoot a DNS problem, you need to know that DNS is actually used for name resolution. After determining that DNS is part of the process, you can begin monitoring DNS. If the problem is performance related, or you can troubleshoot DNS queries and zone activities when there are query failures. DNS troubleshooting. Windows has several tools to administer, monitor, and troubleshoot DNS server operations, including DNS Manager, DC diagnose/test DNS, DNS command.exe, PowerShell event viewer, DNS int NS lookup, which I can guarantee that we've gone over before and will come up over and over again. IP config, which you should know by now, performance monitor, and protocol analyzer. In order to troubleshoot DNS queries, you need a clear picture in your mind of the DNS lookup process, which involves the following steps. This one is another one that you might want to keep. Check the local DNS cache. Query the DNS server with a recursive lookup. Check the local zone data. Check locally cached data. Query root server or configured forwarders. To verify DNS configuration, use these IP config options. So when you're typing these, it's like we've done before. It's IP space and then the slash. So IP space / all. This is everything for your IP address. Display DNS displays your local DNS cache. Flush DNS, that will delete your local DNS. And they don't list it on here, but if you want to do a renew, you can do a renew and it'll renew it. After these steps, double check the host file to make sure you don't miss something when you display the local cache. There are times I do wish there was an IP delete my computer. There are some people that it would probably behoove us to have that option. If everything checks out on the client, you need to analyze the DNS server the client uses, including examining the following: locally cached data, DNS server logs, verify Active Directory replication, verify SRV records, verify zone transfers, verify zone delegations, ping, which honestly, when it comes to me, ping is usually higher up on the list, and verify PTR records. All right, that probably hurt. So that's it for that particular fun, brain-melting presentation. Are there any, I blinked and it ended, yes. That's probably called a fugue state, Gustavo. So are there any questions about what we just went over? My suggestion is you give it a little bit to ferment and either watch the video again or go through the PowerPoints. And then tomorrow we will meet back and I will hopefully have some test VMs for us to play with tomorrow so that we can get our feet wet on that. Otherwise, go do your stuff and then just let me know if you have any questions. Hop on, I'll be here and I'll get this uploaded on YouTube here in just a few minutes. Guys, have a great night, okay?